In this episode, we focus on a problem that shows up in almost every organization that adopts AI quickly. The technology spreads faster than the architecture. People find a tool that feels helpful, they connect it to data or workflows, and soon the organization has multiple AI systems operating outside normal oversight. Those are shadow systems, meaning they exist and create risk, but they are not fully visible to the teams responsible for security, governance, and reliability. The purpose of Task 11 is to prevent that outcome by integrating AI architecture into enterprise architecture, which is the organization's overall blueprint for how technology is designed, approved, connected, and managed. Integration is not about slowing innovation or banning new ideas. It is about making sure AI systems follow the same disciplined rules as other business-critical technology, so they inherit mature identity standards, data controls, monitoring practices, and vendor governance instead of operating as isolated experiments. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. To understand why shadow systems happen, it helps to look at the incentives that create them. AI tools can be easy to adopt, sometimes requiring only an account and a quick connection to existing data sources. Teams under pressure to deliver results may choose speed and convenience, especially when they believe the work is low risk or temporary. Another driver is that enterprise processes can feel confusing to beginners and non-technical teams, so they may bypass formal architecture reviews to avoid delays. Shadow systems can also emerge when there is no clear approved path for AI experimentation, forcing people to improvise. The security risk is that improvised systems often skip key controls, such as strong identity, least privilege, data classification checks, retention rules, and incident response planning. Even if the team had good intentions, the result is a system that can leak data, produce unsafe outputs, or become a hidden dependency that breaks later. Enterprise architecture exists to prevent this kind of ungoverned sprawl by creating consistent patterns. Think of enterprise architecture as the organization's shared language for systems, how identities are managed, how networks are segmented, how data is stored, how applications communicate, and how changes are approved. When AI architecture is integrated into enterprise architecture, it uses the same language. That means an AI system does not invent its own identity model. It uses the organization's identity approach. It does not create random data copies in unknown locations. It follows data standards and classification rules. It does not rely on undocumented integrations. It uses approved integration patterns with monitoring and logging. Integration makes AI systems easier to secure because they ride on known, tested practices rather than creating exceptions that nobody can track. A major beginner lesson is that integration is not a single meeting or a single diagram. Integration is a design choice repeated across many decisions. For example, when a team wants to add an AI feature, integration asks whether they are using an approved platform or a controlled access path rather than a personal account with unknown settings. When the feature needs data, integration asks whether the data access follows established controls and whether the data is allowed to be used for that purpose. When the system needs to connect to other applications, integration asks whether those connections follow approved patterns that can be monitored. When the system needs to be updated, integration asks whether changes follow the organization's change management expectations. Each of these decisions reduces the chance that a shadow system will appear, because the approved path becomes the easiest path. It is also important to recognize that shadow systems can be internal or external. An internal shadow system might be a model hosted by an individual team that is not registered, not monitored, and not aligned with enterprise standards. An external shadow system might be a vendor tool used by a team without procurement review, contract protections, or clear data handling agreements. Both create similar risks: unclear trust boundaries, unknown data flows, weak oversight, and limited incident response readiness. Integration into enterprise architecture reduces both types by setting clear expectations for onboarding systems, approving vendors, and documenting how services interact. For beginners, It helps to remember that a system can be risky even if it is not malicious, simply because nobody is accountable for it. A practical way to avoid shadow systems is to create a clearly defined entry point for AI projects. The idea is that teams should know where to go when they want to build or adopt an AI capability, and that path should be fast enough to compete with the temptation to bypass it. In enterprise architecture terms, that entry point might include approved reference architectures, approved integration methods, and approved data access patterns. The goal is not to force every team to reinvent security. The goal is to provide building blocks that make secure choices easy. When the organization offers a standard way to authenticate users, log AI usage, and control data flow, teams can focus on the business problem instead of creating ad hoc systems. Shadow systems often happen when the secure route is unclear or overly difficult. So a good integration approach reduces friction while maintaining controls. Another key integration concept is lifecycle ownership. A system is not just built, it is operated, monitored, updated, and eventually retired. Shadow systems often lack clear ownership for those phases, which is why they become dangerous. If nobody owns monitoring, misuse can go undetected. If nobody owns updates, vulnerabilities can remain unpatched or models can drift without oversight. If nobody owns retirement, old systems can keep running with outdated data, outdated controls, and forgotten access paths. Enterprise architecture typically includes expectations for ownership, operational support, and service continuity, and integrating AI systems into that framework ensures these expectations apply. Beginners should understand that ownership is a security control because clear ownership means problems have a responsible party and a response plan. Integration also improves security because it encourages reuse of proven controls. Enterprise environments often already have standards for authentication, logging, data retention, network segmentation, and vendor management. When AI systems integrate into that environment, they inherit those controls rather than building new ones from scratch. This reduces errors and reduces variation, and variation is a common source of security gaps. If every team builds a different way to handle AI prompts and logs, some teams will inevitably make unsafe choices. If everyone follows a consistent pattern, it becomes easier to protect data, detect anomalies, and audit compliance. Consistency also makes training easier because staff learn one approach and can apply it across systems. A subtle but important risk of shadow systems is that they can create hidden dependencies. A team may adopt an AI tool for a small experiment. Then the tool becomes essential to a workflow, and suddenly the organization relies on it without realizing it. When that vendor changes pricing, experiences an outage, or suffers an incident, the organization is caught unprepared. Integration into enterprise architecture reduces this by making dependencies visible and documented. Visibility allows the organization to plan for resilience, including backups, failover strategies, and alternative workflows. Even if you do not build these plans immediately, simply knowing the dependency exists is a major improvement over surprise reliance. Beginners should remember that resilience is part of security because availability failures can be just as damaging as breaches. Governance and audit alignment is another reason integration matters. If AI systems are scattered and undocumented, it becomes difficult to show how data is protected, how access is controlled, and how risk is treated. That can create problems with internal accountability and external requirements. Integrated architecture supports governance because it creates a consistent story. Systems are registered, data flows are documented, controls are assigned to owners, and monitoring is in place. Auditors and leaders are not looking for perfection. They are looking for evidence that the organization understands its systems and manages risk responsibly. Shadow systems undermine that evidence because they create unknowns. Integration reduces unknowns by design. None of this means that experimentation must stop. A mature approach allows safe experimentation within controlled boundaries. For example, an organization might allow prototypes using approved datasets, restricted environments, and limited access, while still requiring registration and basic monitoring. The key is that even experiments should not be invisible. If an experiment touches sensitive data or interacts with customers, it should follow stronger controls immediately. If an experiment is low risk, it can follow a lighter but still documented path. This flexibility is part of integrating AI into enterprise architecture because it recognizes different risk levels while maintaining visibility and accountability. The success measure is that people stop feeling the need to hide AI work to get it done. To close, integrating AI architecture into enterprise architecture without shadow systems means making approved, secure patterns the default way AI is adopted and built. Shadow systems are risky because they create hidden trust boundaries, unclear data flows, weak identity and monitoring, and uncertain ownership. Enterprise architecture provides standards for identity, network, data, logging, and lifecycle management, and integrating AI into that framework lets AI systems inherit mature controls rather than inventing exceptions. The practical outcome is not bureaucracy for its own sake, but a safer, more reliable AI environment where teams can innovate while the organization maintains visibility, consistency, and accountability. Task 11 is about building that bridge between AI enthusiasm and enterprise discipline so the technology grows safely instead of quietly creating risk.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.